Okay. Now we need to find 4-point DFT. Okay. Now we need to find 4-point DFT. Okay. We need to find 4-point DFT. That means, okay, that means 4-point means you should have 4 frequency sample. That means 4 frequency samples should be there. Okay. So that means, okay. So if you get the DIFT signal, okay. If you apply DIFT to accept, you will get this kind of signal. No? This omega is a continuous time signal. Okay. So now you need to get only 4 samples from this signal. Okay. So let's say that once you get xn, so you will have this kind of signal. We don't know any signal. Okay. Now 4-point means, okay, you need only 4 sample here. Okay. The endpoint means n sample. Endpoint means there should be n frequency sample. Okay. So that is the n definition. N meaning. Okay. The meaning of the n means n frequency sample. That is number of frequency sample. Because this is a frequency time signal. No? So we have to talk about frequency sample. Correct? Make a frequency signal එකක් හින්දා මේක frequency domain signal එකක් හින්දා අපි frequency sample තමයි ගන්න ඕන. time sample නෙවෙයි. මේ n කියන්නේ time sample. හරි? දැන් අපිට ගන්න ඕන n 4 point. ඒ කියන්නේ අපි 4 sample ටිකක් ගන්න. හරි? මේ omega ගෙන් sample 4ක් ගන්න ඕන. මොකක් හරි time එකකදී sample එකකට. හරි? Right. That means, okay, that means our K should have only 4 samples. That means K should have from 0, 1, 2, up to n minus 1. That means n is 4. No? So n minus 1 is 3. Okay. So you should have only 4 samples here. 1, 2, 3, 4. The sample should be starting from 0. Okay. Then you will have 0 to n minus 1. So you will have n sample. 0 to n minus 1 means here you have n sample. Number of n sample. Okay. So in this case, it is a 4-point DFT. No? So you will have only 4 samples. That is 0, 1, 2, 3. Okay. So these are the samples 0, 1, 2, 3. Okay. So K from 0 to 1, 2, 3. Okay. Now you need to find okay. So now you need to find xk. Okay. So to find xk, you are given this identity. Okay. You need to find xk. Okay. To find xk, you are given this identity. That is, what is that? Sigma n from 0 to n minus 1. Sigma n from 0 to n minus 1 xn e to the power, sorry, not e to the power, w n k n. Okay, so this is the identity. Okay, so now you need to, you know that w n k n is equal to e to the power minus j 25n into simple n, no, sorry, kn into kn. Okay, so this is wn kn, definition of wn kn. හරි, දැන් මේක කට්ටියට එච්චර පැහැදිලි නැතුව ඇති. හරි, අපි ගණන් දෙකක් තුනක් හදමු, එතකොට තේරෙයි ඈ. හරි, wn kn. හරි. Okay, now, okay, so this is endpoint. So this is the endpoint, no? So now here n is equal to 4. Okay, now here n is equal to 4. So we have to find xk from n 0 to n minus 1, that is 3 xn e to the power, sorry, wn means w4 kn. Okay, so here 4, this n should be 4, so it will be 5 by 2, no? So w4 kn is equal to e to the power minus j, here 2 4 divided. Okay, so it will be 5 by 2 kn. Okay, so this is w4. Okay, now you need to uh, you need to expand this. Okay, you need to expand this. Okay, so you have to now already you already know that k from 0 to 3, 0 k 0 3 0 1 2 3. Okay, now you have to find this xk now. So you have to find x0 x1 x2 and x3. Okay, because the k from 0 1 2 3. Okay, so here you can uh, write x0. Okay, that is k is equal to 1. So it is equal to sigma 0 to 3 xn, here w for kn. So here I will write directly this one. Okay, so w4, that is e to the power minus j pi by 2. Now the k is equal to 0. Okay, k is equal to 0 and you have n. Okay, so this is multiplied by 0 means e to the power 0. So you will have only 1. Okay, so now x0 is equal to, this is capital 1. Okay, capital x0 is equal to 0 to 3 xn. Okay, so 0 to 3, 0 to 3. Okay, so you have to consider only the plus sample. Okay, there is our xn. Okay, so this is xn. Okay, so this is the 0th value. Okay, this is the 0th value, you can assume it, this is the 0th value. Okay, so x0, so you will have x0 plus x1 plus x2 plus x3, 0 to 3, x0, x1, x2, x3. When n is equal to 0, n is equal to 1, 2, 3. The n should be 4 minus 1, no? 3, up to 3. Okay, so you can add them together, x0, x1, x2, x3. Okay, so what you have? x0 is 0, this is 1, this is 2, and this is 3. So you will have to add them together. 0, 1, 2, 3, that is 6. Okay, so that is x1, the value of x0. Okay, so let's say that you need to find x1, capital X1. So how you have to find the value? Okay, so you have to write the same way. Okay, now the k is equal to 1. Okay, now the k is equal to 1. Okay, so you can write this expression 0 to 3 xn. So now k is equal to 1. Okay, k is equal to 1. Here this is equal to 1. Okay, so I will directly write the e terms here, e to the power minus j 5 by 2, k is equal to 1 n. Okay, so now you have these e terms. Okay, now you have to consider this t terms also. Okay, so now you have to again find 0 to 3. You have to expand this, so you will have x0 e to the power minus j 5 by 2, k is equal to 1, n is equal to 0, plus x1 e to the power minus j 5 by 2, 1 into n is again 1 now. Okay, plus x2 e to the power minus j 5 by 2, 1, n is equal to 2, plus x3 e to the power minus j, pi by 2, 1, x is, n is 3. Okay. So you can like this. Now you have to find x1, you have to simplify this. Okay. x0 is 0. So this will be 0. x1 is 1. So you will have e to the power minus j pi by 2 plus x2 is 1. Okay, x2 is 1. This is x0, this is x1, this is x2, this is x3. Okay, so x1 is 1. Okay, sorry, x2 is 2. So you will have 2 e to the power j, this 2 and this 2 cancelled out, you will have j 5 plus x3. x3 is equal to 3, no? x3 is equal to 3. So you will have e to the power minus j 5 by 3, 5 by 2. Like this. Okay. So this is, you have to simplify. Okay. So I will, so there is a simple way to simplify this. Okay. Now you no need to go to that process. Okay. But you can get the value here actually very easily. Okay. I will tell it later. Okay. I will tell it later. You can conclude this value. Okay. Now you can use a calculator and also conclude. Actually, uh, uh, it is easy to calculate this in this method rather than using the calculator. Okay. But now still I hope you can't understand this process. So I'm not going to simplify this further. Okay. So this is the answer for x1. Okay. So that is enough, I think. Okay. Now again, you have to find x2, and in the same manner, you have to find x3. Okay. So try to find x2. Try to find x2 also by yourself. Take 5 minutes and see this example and try to find that. Now the k will be equal to 2. Okay. That is the only difference. This k will be equal to 2. Okay. So this k will be equal to 2 means here also k will be equal to 2. Okay. So once you are writing this exponential terms, this value will be 2. That is the only difference. Okay. So same way you can find x2. Okay. So try to find this in exponential terms. You no need to simplify this. Try to find up to this. So try to find this x2. So maybe now you should be still, you may be not familiar with this process. Okay. But try to understand and try to do by yourself. Take effort. Okay. If you can't do it, that is okay. Just take effort. So okay, we will get this one, no? 6. x0. x0 we have get 6. Okay. So our answer is correct. Okay. And if we simplify this, okay, you will get this value. Okay. Let's see later how to simplify this one. Okay. So that is also easy. Okay. I will tell you anyway how to simplify this one later. Using a calculator, you can simplify this one. Okay. Using a calculator, you can simplify. And also using the Euler formula, also you can simplify this. Okay. Euler formula and the calculator. Using the Euler formula, you can write this in cos term and sine term. So you can have these are values now, pi by 2, 5, 3 5 by 2 likewise no. Okay, තේරුණාද? එතකොට cos theta sin theta වලට calculator එකෙන් value හොයාගෙන මේ වගේ value සුළු කරන්න පුළුවන් ඔය කට්ටියට. හරි? Try to find the x2. So now I am actually so try to do this one yourself. Okay. Meanwhile, okay. So so you know that if we consider ej theta, this kind of one, okay. So you know that this is a complex number, okay. That is in polar. What is this? It is in polar form. This theta is the phase, okay, and the magnitude is here. For this complex number, magnitude will be 1, okay. So this kind of one, okay. So the magnitude means this distance will be 1 and this theta can be anything. So your complex number will be here, okay. So let's say that this is this kind of circle. If we consider this kind of circle, so you can see that if this theta is 0, that means your theta is here, okay. So this is the theta is equal to 0 and this is the theta is equal to 5 by 2. This is the theta is equal to 5. This is theta is equal to 3 5 by 2 and again this is theta is equal to 2 5, okay. So you can see that if we have ej0, that is 1, your point is here. ej5 by 2, this is imaginary axis, okay. This is imaginary axis and this is real axis. This is j axis. If it is e5 by 2, that means you are here, no. So that value is plus j, okay. So this will be equal to plus j, okay. And if you consider 5, if the theta is equal to 5, that means ej5. So you are here, no, okay. So that means it is minus 1, okay. If theta is equal to j 3 5 by 2, that means you are here, that is equal to minus j, okay. So likewise you can easily find this 0 5 by 2 5 3 5 by 2 like this, okay. So if you consider minus value, let's say that e to the power minus j 5 by 2, okay. So this is minus, no, minus means this direction. So minus 5 by 2 is here, this one, that is equal to 3 5 by 2. 3 5 by 2 is ideal to minus 5 by 2, okay. So that is here, so it will be minus j, okay. So in that sense you can easily find the value here actually, okay. So for example, this is minus 5 by 2, that means here, that is minus j. So you will have minus j here, plus you have 2 here. This is e to the power minus 5. Minus 5 means this direction here. So that is minus 1. Okay, that is minus 1. 2 minus 1 plus 3 e to the power minus j 3 5 by 2 minus 3 5 by 2. Minus 3 by 2 means this direction 5 by 2. That means here. Minus means this direction, okay. So that means it is here at 5 by 2. That means it is equal to plus j. So it is equal to plus j. So you can see that plus 3j minus j, it is equal to 2j. 2 into minus, it is equal to minus 2, okay. 2j minus 2. So you can easily actually calculate that value, okay. So that is 2j minus 2. Okay, no? 2j minus 2. This is the value. Okay. So likewise, you can calculate. Okay. So anyway, try to find. Okay, maybe if you are not familiar, because still you are not familiar with this, maybe it may be hard to do. Okay. So I will do it now again. Okay. Now you need to find xk. Okay. Now we have found k is equal to 0, k is equal to 1. Now we have to find the k is equal to 2. Okay. That is x2. That is equal to n from 0 to n minus 1, capital N minus 1. Capital N means the number of sample. Now we are given n is equal to 4. Okay, so 4 minus 1, you will have 3 here. Xn, okay, xn. So you will have wn, that is 4. K is equal to 2n. Okay, so this W4 to n is equal to e to the power minus j 25n, that is 5 by 2, 25n, n is 4, no? So 2 to cancel, you will have 2 here, 5 by 2, k, that is 2n. Okay, so this is equal to W for 2n. Okay, so now you can apply it here. So you will have x2 is equal to sigma n from 0 to 3 xn e to the power minus j 5 by 2 2n. Okay, so this 2 and 2 you can cancel out. Okay, so you will have sigma n from 0 to 3 xn e to the power minus j 5n. Okay, so you will have this one. Okay, now you have to expand. Okay, how to expand? First one, 0. N is equal to 0. X0 e to the power minus j50. So it will be e to the power 0 plus x1 e to the power minus j5 n is equal to 1 plus x2 e to the power minus j5 n is equal to 2 to 5. Okay, plus x3 n is equal to 3, x3 e to the power minus j5 n is equal to 3. This way, 3 5. Okay, so you know x0 is 0, so this will be 0. X1 is 1, so you will have e to the power minus j5 plus x2 is 2, 2 e to the power minus j25 e to the power minus j2, so minus j2 e to the power minus j25. Okay, plus x3 is equal to 3 e to the power minus j35. Okay, so if you can find up to this one, you will get full marks, but you can easily, this one also you can easily find the value, because here you have 5, 2, 5, 3, 5. What is e minus j5 value? Can anyone tell me what is e minus j5 value? So ej5 you can write in this circle. Okay, so this is theta. Now theta is equal to minus 5. Minus 5 means this direction. Here, this is minus 5. So what is this value? It is minus 1. Okay, so this one value will be minus 1. And 2 e to the power minus j25. What is minus j25 value? What is value this value? What is the value of this one? You should be able to tell this one. Make value එක මොකක්ද? E to the power minus j25 වල value එක මොකක්ද? 25 කියන්නේ කොතනද? කොතනද? මෙයා කැරකිලා කොතෙන්ද දෙන්නේ? මෙයා කැරකිලා ඔහම කහට එන්න ඕනද 25 වෙනකොට? point 1 to the point 2 to the point 3 to the point 4 ට දෙන්න ඕන. මෙතන ඉඳන් කරකිලා 25 වෙනවා නම් -25 ඒ කියන්නේ මෙයා කරගෙන මේ පැත්තට +25 නම් කරගෙන මේ පැත්තට. You have to remember that. ටග්ගල කියන්නේ 25 නම් කීයද වැලියු එක? 25 නම් කීයද වැලියු එක? -25 නම් මෙතන ඉඳන් මෙතෙන්ට -5 මෙතන ඉඳන් මෙතෙන්ට -25 ආපහු මෙයා මෙතන වැලියු එක කීයද? 1. Okay, so it value will be 1 and here 3 e to the power minus j35. Okay, 35, what is the 35 value? මොකද්ද 35 කියන්නේ? -35 value එක කීයද? මෙතෙන්ට 5 මෙතෙන්ට -2යි 5 -3යි 5 වෙන්නේ කොතෙන්ද? -3යි 5 වෙන්නේ මොකද කොතෙන්ද? මම හරි උත්තරයක් කියන්න ඔකට හිතලා. වැරුණා කමන්නේ. Tell me any answer, give me any answer. Quickly give me. Not 0. 0 means maybe you are here. Okay. Actually, this value is 1. Okay. Okay. If you can represent any EJT like this. Okay. This is a complex value. No? So you can represent in complex plane. This is J. This is imaginary axis. Okay. And this is real axis. Right? Make a J. ඔකට TJT කියන එක මේක complex number එකක් හරි. එයාව represent කරන්න පුළුවන් මේ complex plane එකේ. This is a complex number and you can represent this number in this complex plane. Okay. So you have studied the complex plane. So you have real axis and imaginary axis. This is x-axis is the real axis and the y-axis is the j-axis. Okay. So you can represent this EJ theta is like this. Okay. So what is the phase of this number? That is theta. Okay, the phase is theta. The magnitude is 1. Okay, so this value, the length will be 1. Okay. Okay, so yeah, very good. Okay, yeah. Okay, I got one correct answer. Kisar, check again. Okay, so this will be 1. Okay, and here so let's say that this theta, now this is the theta. Okay, this theta is 5/2. That means this theta is 5/2 means your value is here in this axis. Okay, so it is 1. This point is moved to here, 5/2 here. So that means it is in J. If it is 5, this theta is 5 means now you are here. That means your value is -1. If theta is 3/5/2, you are here. That means your value will be -8. If 2/5, you are again here. That means this value is 1. This is -1. This value is 1. This is +j and this is -j. This is a circle with radius 1. Okay, it is a circle with radius 1. Your number, if theta is changing, that value is changing in this circle. For this circle, the radius is 1. මේ theta වෙනස් කරනකොට ඒ නම්බර් එක කැරකෙන්නේ මෙන්න මේ array එකක් වෙන circle එක දිගේ. හරි? තේරෙනවද? දැන් කියන්න ඍණ 3/5. ඍණ 3/5. දැන් ධන පැත්තට කතා කරනකොට මේ පැත්තට කැරකෙන්නේ ඍණ නම් ඕක මේ පැත්තට කැරකෙන්නේ. මෙතන ඍණ 5/2. මෙතන ඍණ 5. මෙතන ඍණ 35 by 2. මෙතන ඍණ 25. මේ පැත්තට කරගෙනකොට. හරි. දැන් මෙයා කරකෙන්නේ මේ පැත්තට. මේ පැත්තට. එතකොට ඍණ 35 කියන්නේ කොතනද? What is minus 35? You are rotating in this direction, in this circle. This is minus 5. This is minus 25. And this is minus 35. Okay. So you are in this point. So that is minus 1. The 3 minus 1. This 1 is equal to minus 1. Okay. E to the power minus j35 is equal to minus 1. So you can have minus 1 plus 2, that will be plus 1, plus 1 minus 3, that will be minus 2. So that is the answer of x2. Okay. Minus 2. Yeah, minus 2. Okay. So that is the answer for x2. This is the answer for x2. Okay. So in the same manner, you should be able to find the x3, and I think you can now simplify it. Okay. Maybe very easily also, that can also, I'm not sure. I hope මේවා දිහා බලනකොට තේරෙන්නේ අර විදිහටම තමයි. අර 1 වලයි ඍණ j වලයි තමයි අනිවාර්යයෙන්ම rotate වෙන්නේ මෙයා. හරි? එහෙම වුණොත් x3 වාට මෙයාගෙන් ලේසියෙන් හොයන්න පුළුවන් වෙන්න ඕන. Okay. So try to find this one x3 and try to get this answer. x3 and try to get that answer. You need to find x3, and x3 is equal to, I don't know, the capital x3. Okay. This 3 is the k number, kth value. K is now equal to 3. Okay. So try to find this value and try to get the answer. Take 5 minutes, please. Try to do this. Okay. මේක කරන්න මේ වගේ ගානක් එනවා exam එකට. Okay. So you will get this kind of question. Okay. Same question. හරි. මේ වගේම ප්‍රශ්නයක් එන්නේ. අමාරු කරලා දෙන්න මේක ආය හොයා කට්ටියට හිතන්න දෙයක් නැහැ. මේ procedure එකට ඔය කට්ටිය පුළුවන් නම්. Okay. So now you need to find x3. Okay. Now you know that. Okay. I will tell you at the beginning. Okay. So we are given a sequence, that is xn. Okay. So that is 0, 1, 2, 3. Okay. And this is 0. Okay. This is n is equal to 1. This is n is equal to 2. This is n is equal to 3. That means this is x0. This is x1. This is x2, x3. Okay. Now you need to find the discrete Fourier transform of this xn. Okay. So if you find discrete Fourier transform, you will get a frequency sample. Okay. Now you are asked to, the number of frequency sample is denoted by n. Okay. So this is the number of frequency sample, n. Okay. So that is the number of frequency sample. That is the number of frequency sample. Frequency sample gone. Now we are asked to find 4-point DFT. That means we have to find only 4 sample. Okay. Only 4 sample of this xk. Okay. That means we have to find the sample from 0 to n minus 1. That means 4 sample. The k should be from 0, 1, 2, up to n minus 1. N minus 1 is 3. So you have to up to 3. So here you can see that we have 4 samples. So that is why we are asked to find 4-point DFT. That means you have to find 4 samples. Okay. That means you have to find x1, you have to find x2, you have to find x3, and you have to find xc. Okay. So we have found this one, we have found this one, we have found this one, we have found this one. Okay. So that is xk. These are the frequency domain samples. These are frequency domain samples. Okay. Now you need to have sample. Okay. Otherwise, it will be a problem. Okay, when we are digitally processed. Okay, so that is why you are converting this. So if you get direct DIFT, direct Fourier transform, discrete time Fourier transform. Okay, so you will get omega domain signal, and this omega is a continuous time. Okay, continuous variable. So you need to get some sample. Okay, so that is why you are using DFT. Okay, so now you have to get 4 points: x0, x1, x2, x3. Okay, so commonly k is given as n from 0 to n minus 1 xn. Okay, and here it is mentioned in w. Okay, wn kn. Okay, this wn kn is defined as e to the power minus j 25 this n, capital N, and this kn. Okay, so this is the wn. Okay, so here instead of this wn kn, you can directly use this one, no problem. Okay, no problem. Okay, now n is equal to 4. Okay, so if I write this one, w4kn, n is equal to 4, no? N is equal to 4, w4kn, you will have e to the power minus j 25 by 4 kn. This is simple n. Okay, this is capital N. Capital N is 4 now. So 2 cancel out, you will have w4kn is equal to e to the power minus j 5 by 2, and the kn is there. So this is w4k. Okay, so you can directly use this one. Okay, so that is how we can get we have get 5 by 2. Okay, now you need to find the k is equal to 0. Now you need to find k is equal to 0 point. K is equal to 3, sorry, that means xk. Okay, k is 3 means this k is 3. Okay, so here this k also will be 3 here. Okay, so xk will be sigma n 0 to capital N minus 1. Capital N is 4. Okay, so n minus 1 means 4 minus 1, that is 3. Capital N minus 1 means 3. Okay, xn. Okay, so I will write this w4k, that is 3n, directly here. That is e to the power minus j 5 by 2, k is equal to 3n. Okay, so this is this one. Okay, this term is this one. I have directly write it, this w term here. Okay, so now you have to expand this, very easy. Okay, so n is equal to 0, x0, e to the power 0, plus n is equal to 1, x1, e to the power minus j, here 3, no? So you will have 3 5 by 2, n is equal to 1. Okay, n is equal to 1 plus x2 e to the power minus j 3 5 by 2, n is equal to 2. So this 2 and 2 cancel out. So you will have only 3 5. Okay, plus x3 e to the power minus j 3 5 by 2 is equal to 3. Okay, so it will be 9 5 by 2. Okay, it will be 9 5 by 2. Okay, so now you have to simplify this. Okay, so x0 is 0, e to the power is 1. So 0 into 1, that is 0. x1 is 1, e to the power 3 5 by 2 minus 3 5 by 2. So you have to again use the circle. Okay, so when the theta is changing, you are moving in this circle, that is radius will be 1. Okay, now it is minus 3 5 by 2. Minus means this way. Okay, so this is 0, this is 5 by 2, minus 5 by 2, this is minus 5, and this is minus 3 5 by 2. Minus 3 5 by 2 is equal to plus j. Okay, so this will be equal to plus j. Okay, plus x2 is equal to 2 e to the power 3 5 minus 3 5. 3 5 means this is 5, this is 2 5, this is 3 5 when it is here. Okay, so that will be minus 1. 2 minus 1 plus x3. x3 is equal to 3 e to the power minus j 9 5 by 2. The 9 5 by 2 calculate. You have to calculate. Okay, so minus 9 5 by 2. ඒක ගණන් කරන්න පුළුවන් ලේසියි. මේ 1 5 by 2 එක. Here. Okay. Okay. This is 1 5 by 2. Okay. This is another 5 by 2. 5 by 2, second 5 by 2. This is third 5 by 2. This is fourth 5 by 2. This is again, this is fifth 5 by 2. 6 5 by 2. 7 5 by 2. 8 5 by 2. 9 5 by 2. 9 5 by 2 is here again. So it will be minus j. Okay. මේක තේරුණාද මේ 9 5 by 2 ගණන් කරපෑදී. දැන් මෙතන ඉඳන් මෙතෙන්ට 5 by 2. මේ තව 5 by 2 එකක් නේ. මේ දෙවෙනි 5 by 2 එක. මේ තව 5 by 2 එකක්. එතකොට ඒ තුන්වෙනි 5 by 2 එක. ඒ කියන්නේ 3යි 5 by 2. මෙතන එන්නේ 4යි 5 by 2. ඒ කියන්නේ 4යි 5 by 2 කියන්නේ 2යි 5. හරි? ඊට පස්සේ මෙතන එන්නේ 5යි 5 by 2. ඒ කියන්නේ 2හමාරයි 5. මෙතන එන්නේ 6යි 5 by 2. මෙතන 7යි 5 by 2. 8යි 5 by 2. 9යි 5 by 2. ආපහු මෙතෙන් තමයි එන්නේ. ඒ කියන්නේ ඍණ j. 3 ඍණ j. So you can easily this one you can this one, so 2 into minus 1, this will be minus 2 minus 3j plus j, so you will have 2j. Okay, minus 2 plus 2j. Minus 2 minus 2j, no? So I think we have done a mistake here. Okay, let's check it again. The answer should be minus 2 minus 2j. But we get plus 2. Oh, sorry. Yeah. It is correct. Here minus 3j, no? Minus 3j plus j. Minus 3j plus j. So that is minus 2j. Okay. I'm sorry. And Nikila adu වැඩි කරේ මෙතන එන්නේ minus 2යි. ඍණ 3යි j වලින් ධන j ගියපුවාම ඍණ 2යි j. ඍණ 3 ධන 1 ඍණ 2නේ. හරි. So you will get this one. Okay. So that is it. Okay. දැන් ඒක හරි තේරුණාද? Okay. Anyway, I will give you another question. Okay. I will give you as a homework. Okay. I'm not going to do it here. Okay. But I will give you, and you need to try this. If you can't do this, you have to ask from me. Okay. Next week, you can come and meet me, then you can ask, okay? Okay. Try to find the discrete Fourier transform of this one. Okay, you have to find the, I think you can do this, okay? Discrete Fourier transform of this one, df/dx. Okay, find fifth point dft. Okay, 5-point dft. Try to find 5-point dft. Okay, so how to do is that, so you can find n0, n1, n2, and n3. Okay, so you can find x0. X0 is n is equal to 0. That means cos 0. Cos 0 is 1. So x0 is equal to 1. Okay. X1, that is n is equal to 1. That is cos 5 by 2. Cos 5 by 2 is equal to 0. Likewise, you can find cos 0, cos 1, cos 2. Sorry, x0, x1, x2, and x3. Okay. Okay. Now you are asked to find the 5-point dft. That means at least this sequence should have 5 points. Okay, this n should go to 4 and 5 volts. Okay, but your signal is, the given signal is only limited here. Okay, only limited here. Then you have to add additional sample, but those should be zero sample. Right? Zero sample should be added. Okay, actually those is called zero padding. Okay, that is called zero padding. Okay, අපි ඒකට කියනවා zero padding එක කියලා. ඒ කියන්නේ ඔකට දීලා තියෙන signal එක 3ට යනකල් විතරයි තියෙන්නේ. හරි? මෙන්න මේවට value වෙනවා. x0, x1, x2, x3 you have some value. And x4 and x5 you doesn't have value. But if you ask to find 5-point DFT, you should have at least 5 points. Okay, 5 points. So what you have to do is you have to simply add 0 to this point. තව 0 දෙකක් එහා පැත්තට දාගන්න එක තියෙන්නේ. දාලා 5-point DFT එක හොයන්න තියෙනවා. Okay. So try to find this one, and if you can't do this, please come and ask me. Okay, then I will explain how to do this. Try to do it. Try to do this by yourself. Okay. Okay. So we will stop here, and I will. So anyway, we have very important 2 parts actually. Okay, that is F50. We called F50. Actually, this is so this DFT. Practically, we use this DFT. Okay, discrete Fourier transform. Practically, we use. Okay, but you can see that when we are doing this DFT in circuits level, it will be very hard if the number of sample is increasing. අපි මේක circuit වලින් කරන්න යනවා නම් මේ number of sample වැඩි වෙනකොට discrete Fourier transform එක හරි අමාරු වෙනවා. හරි? So we have some algorithms. හරි? එතකොට අපිට පුළුවන් algorithms පාවිච්චි කරන්න. ඒ කියන්නේ microcontroller එකේ algorithm එක අපිට පුළුවන් store කරන්න. Okay, we can store algorithm in the microcontroller RAM or ROM. Okay, then you can find the DFT. Okay, so there are many algorithms, and this F50 is also algorithm. It is called fast Fourier transform. Fast Fourier transform. It is a one algorithm, very popular algorithm of DFT. Okay, so you have to learn this algorithm F50, and you have to learn the analog to digital conversion. Okay, so these 2 terms you have to learn. Okay, but I will not put this into your exam paper, but anyway you have to learn this one. Okay, so maybe I will talk with Dr. Udeshan. I will get a plan from him. Maybe I will give I will give you assignment in this F50 and analog digital converter, but you can submit the assignments after the exam. Okay, no need to do it in the exam time. Okay, because these are not coming to the exam paper. Okay, so for the exam you will come from sampling. Okay, so please remind the sampling. Okay, go through the lectures and try to understand the sampling and try to recap it, and you will have discrete time Fourier series, discrete time Fourier transform, then discrete Fourier transform. So these 4 you will get for your final examination. Okay. Okay, we will stop now. Okay. So try to do this question by yourself, and if you have any problem, you can come and meet me at the lab in next week. Or maybe call. Okay, you can call me, or you can have a Zoom meeting if you are not coming to the campus. Okay. So we will wind up now. Okay. Okay, thank you for participating. If you can't understand anything, please send me a mail or WhatsApp me or ask me. I will explain. Okay. Okay. Then we will stop. Okay, thank you and good night. Okay.
Excuse me, sir.
How can you, sir? Tell me.
Sir, open book the exam.
අපි open book තියමු කමක් නැහැ මේක. මම පොඩ්ඩක් ඒක මෙහෙමයි උදේසර්ගෙන් අහන්න ඕනේ ඉස්සෙල්ලා හරි උදේසර්ගෙන් අහලා එයා කියන එක තමයි කරන්න ඕනේ මම රික්වෙස්ට් කරනවා උදේසර්ට මේක ඕපන් බුක් තියමු කියලා ඉතින් එයා අප්‍රූව් කරන එක තමයි හරි
හරි සර්.
හරි හරි ඕකේ
ඕකේ.
බැරි වෙලාවත් ඕපන් බුක් තිබ්බේ නැත්නම් මම x මේ අවශ්‍ය මේ ඉක්වේෂන් ටික දානවා හරි ඔය කට්ටියට උගන්වන කිසිම
හරි සර්.
ඉක්වේෂන් එකක් මතක තියාගන්න අවශ්‍ය නැහැ ඒ අවශ්‍ය ඉක්වේෂන් මම දානවා. හැබැයි අර කොමන් ඒවා මතක තියෙන්න ඕනේ. දැන් උදාහරණ cos 30 cos 40 ඔය වගේ එකක් ඔකට කැල්කියුලේටරෙන් හොයාගන්න පුළුවන් වෙන්න ඕන. හරි. එතකොට ඊවල ෆෝමියුලා එකක් මතක තියනවා නම් හොඳයි. හරි. සමහරට ඒක දෙන්නත් ඉඩ තියෙනවා. කොකටත් ඒක මතක තියාගන්න. මොකද ඒක අපි දැන් නිතරම යූස් කරපු එකක් නේ. හරි. එතකොට ඉක්වේෂන් හුඟක් වෙලාවට ඔය කට්ටියට දෙනවා. හරි. ඒකින්ද ඒක ගැන එච්චර වරි වෙන්න එපා. හරි. අර නෝට් එක ගේන එන එක මම හරියටම දන්නේ නැහැ උදේසර් අප්‍රූව් කරයිද නැද්ද කියලා. කොහොම හරි ඉක්වේෂන් ටික දෙන එක මම එක්ක ගානත් එක්ක හරි ඉක්වේෂන් එක දානවා. හරි. ඒතර මේක සාමාන්‍යයෙන් මතක තියාගන්න අවශ්‍ය නැහැ ලොකුවට. හරි?
හරි සර්. හරි.
හරි හරි. Thank you වෙනවා.